Welcome to SSR Pharma Media, your trusted source for pharma knowledge. Today we are going to discuss about Pharmaceutical Inorganic Chemistry PIC MCQs series, your exam power boost. So in Pharmaceutical Inorganic Chemistry, we are going to see errors. Prepare, practice, succeed. So in that errors, we are going to cover sources of error, types of error, methods of minimizing error, accuracy, precision and significant figures. So in these 4 topics today we are going to cover. So what is error and sources of error? So what is definition of error? So errors means it's a difference between true value and measured value. The formula for error is equal to measured value minus true value. So it indicates that the uncertainty in the measurement, not necessarily a mistake. Then sources of error. So there are mainly 5 types: instrumental error, observational error, environmental error, theoretical error and personal error. So you take a screenshot of this slide and you read it. So what is instrumental error? It occurs due to faulty instruments. Observational error, so due to incorrect observation of incorrect readings. And environmental error due to temperature, humidity and pressure variations. Theoretical error due to simplifications and assumptions in formula. So wrong formula, when we use wrong formula, that is theoretical error. Personal error, it is the human error, so carelessness, human bias and sometimes fatigues. So we'll move into the questions. The difference between the true value and the measured value of quantity is known as. So the answer is option B, error. So error is defined as the deviation of the measured value from true value or accepted value of the quantity. In experimental measurement, an error represents. So the answer is option B, natural limitation of measurement. So error does not always mean a mistake. It reflects the inherent limitations in instruments and measurements. Which of the following is an instrumental error? So the answer is option B, zero error in a balance. So in instrumental error arises from imperfection or faulty calibration in the instruments. So it is called instrumental error. So its example is zero error in a balance shows. The parallax error occurs due to. So the answer is option C, improper positioning of the eye while taking reading. So parallax error is an observational error that occurs when the line of sight is not perpendicular to the scale. So for example, when we are doing assay, we have to see the burette at right angle. So if we are not seeing at the right angle, so the reading may be mistaken. So that is called parallax error. The error caused due to expansion of a metallic measuring scale in high temperature is, so it is a type of environmental error. So pressure leads environmental error. So environmental factors like temperature, humidity and pressure causes environmental errors. A chemist neglecting to dry a weighing bottle before weighing introduce. So before weighing bottle, the chemist, the persons will not properly dry the bottle. So that causes which type of error? So the answer is option C, personal error. So it's a completely person error. So incomplete drying of the weighing bottle. So personal error arises from individual due to carelessness or negligence. theoretical errors are due to? So the answer is option B, simplified assumption in formula. So when theoretical models neglect certain factors, or it leads theoretical error, or theoretical error may occur. Zero error in a voltmeter is an example of. So the answer is option A, systematic error. So in instrumental, or zero error consistently affects all measurement in one direction. Hence it is called systematic error. Which of the following is not a source of experimental error? So the answer is option C, computational error. So the computational mistakes are blunder, not true experimental errors. Errors due to humidity in weighing sensitive materials are classified as. So option B is called environmental error. So humidity, pressure, temperature, it is all belongs to environmental error. So humidity affects mass readings and causing environmental error. Which of the following is the personal source of error? So the answer is option A, misreading a scale. So that means incorrect reading of a scale. The personal error occurs from observer bias or carelessness. So without properly we are observing means, so that leads incorrect value or misreading a scale. That means personal error. So next we will discuss about types of error. So types of error, there are three types: systematic error, random error, gross error. So systematic errors have definite causes and directions caused by instrument calibration, consistent and observation bias, or faulty theory. So systematic error may correct it. And next is a random error. So random error also known as unsystematic error. So another name is unsystematic error, or unpredictable variations in readings due to random factors, can be reduced by taking average of repeated things. Sometimes it cannot be corrected. And gross error, so means it's a human mistakes such as misreading or incorrect readings, and avoided by careful observations and cross checking. So we move into the questions. The error that remains constant in magnitude and direction is known as. So option B, systematic error. So systematic errors consistently affect all readings in the same direction. Error arising due to unpredictable variations in experimental conditions are called. So it is unpredictable. So means it's a random errors. Option A, it's a random error. So random error due to unpredictable fluctuations. It's occur due to fluctuation during experiments. So accidental may happen, this random error. A large obvious mistake in reading, recording, on observation is termed as. So the answer is option B, gross error. So large obvious mistake in recording on observation is termed as gross error. So gross error results from human blunders or carelessness. Which of the following can be minimized by taking the average of several readings? So the answer is option C, random error. So random error fluctuate. So when we are taking average or multiple reading, minimize their effect. So we can minimize, but we cannot avoid completely. Incorrect calibration of a thermometer produces incorrect calibration. It produces Option C, systematic error. So, systematic error is a predictable and avoidable. So, calibration's error consistently skew all readings in one direction. The random errors are best described as, so the answer is option B, errors that change unpredictably in sign and magnitude. They vary randomly due to small uncontrollable factors. So next we'll discuss about methods of minimizing error. So the methods of minimizing error, there are several methods are there. So we'll see random error. So are minimized or reduced by average repeated measurement. Systematic error, it's minimized by calibrations and correction. Parallax error, it minimized by reading at eye level. Environmental error, controlling laboratory conditions, it can be minimized. Personal error, it minimized automation and proper training. So we'll move into the questions. Which of the following reduces random error? So the answer is option B, averaging repeated measurement. So repeated and averaging reading minimizes the effect of random errors. The systematic errors can be reduced by, so option B, calibrations and corrections. So proper calibrations of instrument and it leads eliminate constant bias. Which practice helps in avoiding parallax error? So the answer is option B, reading at eye level. So reading along the line of sight eliminates the parallax error. Environmental errors can be minimized by, so the answer is option B, controlling laboratory conditions. So stable temperature, humidity and pressures reduces the environmental effects or environmental errors. Next we will discuss about accuracy and precision. So accuracy means the closeness of measured value to the true or accepted value is called accuracy. If the true weight of an object is 50 gram and measured value gives 49.98 gram, the result is accurate. High accuracy, close to true value. So accuracy means it's the closeness of the measured value. So only closeness of the measured value. Precision means the closeness of repeated measurement to each other. So it should be closeness at the same time repeated. When we are taking reading or 4 or 5 times, the 4 or 5 times it should produce the closeness reading. That means, for example, the closeness of repeated measurement to each other irrespective of their closeness to the true value. So repeated weights of 49.85 gram, 49.86 gram and 49.87. So it's the closeness to each other. So these values are called precise but not necessarily accurate. So high precision, it leads consistent results. So precision means repeated value, that means reproducibility. Accuracy means closeness to the true value. So accuracy, precisions. Then what is accuracy, precisions? Now we have seen. So just is a diagrammatical representation. So you read it from this slide. So accuracy means closeness of the measured value. Precision means closeness of repeated measurements. So there is the difference. It's the closeness of measured values, a single value. It's the closeness of repeated measurements. So there is the difference between accuracy and precision. Move into the questions. Accuracy refers to. So the answer is option A, closeness between measured value and true value. So it is called accuracy. So next, if the true weight of the sample is 50 gram and measured value is 49.99 gram. So it is type of whether it's accuracy or precision. So it is a type of accurate. It is called accurate value, closeness of the true value. So this is the true value, is the closeness to the true value. So it is called accurate. Accuracy is affected mainly by, so the answer is option B, systematic error. So systematic error causes consistent deviation from the true value and reducing accuracy. High accuracy in measurement means, so the answer is option B, results close to the true value. Precision refers to, so the answer is option B, reproducibility among repeated measurements. So closeness to the repeated measurement is called precision. If repeated readings are 49.85, 49.86, 49.87 gram for 50 gram of sample, so it's a set of, so the answer is option B, precise but not accurate. So you see among all the options, option A, accurate but not precise, it is wrong. Precise but not accurate is the right answer. High precision ensures, so the answer is option B, small random error. So precision indicates reduced variability due to random errors. Which of the following best represent precision? So the answer is option A, several arrows close together but far from the bullseyes. So precision means closeness of the reading to each other. That means repeated value, not to the true value. So closeness to the each value, not to the true value. So next is a error. So error, significant figures now we are going to discuss. In that error, we are going to discuss about significant figures. So what is mean by significant figures? It's a definition, digit that represent the precision of a measured value. So it is called significant figure. So includes all certain digit plus the first uncertain one. So rules for significant figure, it's a very important for first year pharmacy students and also for MRB and drug inspectors, very important topic this. So all non-zero digits are significant. That means 0 is not a significant figure, non-zero digits are. 0 between non-zero digits are significant. So for example 0.0 means, so 0.0 means 0.0 means this 0 is not a significant figure. So after the number, if 0 is there means, so this 0 is called significant figure. Trailing 0 is in a decimal, numbers are significant. So use scientific notation to clarify significant figures. So we'll move into the question. How many significant figures are there in 0.004560? So in this, how many significant figure means there are 4. So 1, 2, 1, 2, 3, 4. So these 2 zeros are not included as a significant figure. So there are 4 significant figures are there. Option C is the answer. So only 4 significant figure. Before the number, if zeros are there means that zeros are not considered as a significant figure. But after the number zeros are there, that zeros are considered as a significant figure. So the last 0 is a trailing after the decimal and after non-zero is a significant. So next, in 1.050 into 10 to the power of 3, number of significant figure is, so here 1, 2, 3, 4 numbers are there. So the answer is option C, 4 significant figure. 1, 2, 3, 4. So these four numbers are called as significant figure. Next, when adding 12.34 plus 0.456, the correct answer should have, so 2 decimal. So 2 decimal answer is 2, because when we are adding these two, so 12.34 plus 0.456. So this 6 is a significant figure. So significant figure means instead of 6 we will add 1. The 5 is converted into 6. 6 plus 4 10, instead 0 and remaining 1. So 4 plus 3 plus 1 4, 4 plus 4 8 and 2. So it's a 2 decimal. So round off this 5, 6, you can, 1 is you have to include it with 5. So which of these numbers shows a precision of 3 significant figure? So the answer is option C. So 4.50 into 10 to the power of 2. So this is the exact significant figure. So remaining all are not a exact significant figure in this option, because so here 0.00, 2 decimals are not a significant. So only 3 are there. And next is the 0, only 3 decimals. So 0 is not a significant figure. And here there is no 0. So 0 is after the number. So it is representing, this one is the exact significant and best representation of the significant figure. So we should choose this option only. If number of significant figure they are asking means, we can tell the numbers. But correct representation of this question is, answer is option C. So scientific notations clearly indicates 3 significant digit 450. The most effective way to minimize personal error is, so answer in the comment box. Thank you. So all of you join in our WhatsApp community. You will get number of test series and hands out material. Thank you. Like, share and subscribe.